What is a sentiment? A sentiment is an opinion, an emotion, or an attitude. It is not a fact but subjective impressions. Generally, a binary opposition in opinions is assumed for or against, like or dislike, good or bad, etc. Polarity. What is a sentiment analysis, essay? Essay is the process to extract, identify, or otherwise characterize the sentiment content of a text unit. Sometimes referred to as opinion mining. Watch the video. Applications of essay. Some examples of applications of essay. Is this product reviews positive or negative? What are the sentiments of the voters of the coming election as captured on the social media, example, Facebook? Based on a sample of tweets, how are people responding to the advertisement campaign or product release or news item? What are the sentiments of parents toward the introduction of religious studies in primary school? Basics of essay. The basic task involved in sentiment analysis is identifying and quantifying the polarity of sentiments, such as positive, negative, neutral, or mixed, expressed typically in written opinions, expressions, reviews, comments, and so on. Therefore, it involves many of the text analytics steps such as tokenization, sentence identification, part of speech tagging, and so on, that have been discussed earlier. But, sentiment analysis has to go beyond the basic steps in text analytics. For example, often tweets, reviews, and postings have different types of sentences, declarative, imperative, and interrogative, that must be identified because they might not be appropriate for sentiment analysis. A declarative sentence, example, "It is an amazing TV," often states the views of the author and is appropriate for sentiment analysis. An imperative sentence, example, "Do not buy this TV," can be used to infer sentiments about the product. An interrogative sentence, example, "Which is the best TV," might not be a good candidate for sentiment analysis. Just as in text analytics, sentiment analysis requires the analyst to spend considerable time pre-processing text and making a large number of subjective judgments to get meaningful results. Sentiment analysis starts with determining whether a text contains an opinion, sentiment. If it does contain sentiment, at what granularity level does the sentiment exist? Example. From the example, many questions come to mind as you read the review. There are some statements that are clearly subjective and contain an opinion, example, TV is wonderful, and other statements are just facts, example, cannot play video from thumb drive. Considering the opinion statements, is the overall sentiment, in the entire review, about the TV expressed by the customer positive, negative, or mixed? What about the sentiment for attributes of the TV, such as size, picture, and interface? What about the video playing ability of the TV from the USB? Hence, a clear understanding of the level of analysis and the terms used to specify these levels is needed. Document level. At this level, the task is to figure out whether the entire document can be classified as positive or negative. This is possible only if the document involves a single entity, such as the TV in the previous example. If a document involves multiple entities, then it might not be possible to arrive at a document-level sentiment classification. Sentence level. At this level, the task is to classify each sentence in a document as a positive, negative, or mixed sentiment sentence. Example: TV is wonderful expresses positive sentiment. I just want to point out that the 43 TV does not in fact play video from USB express negative sentiment. Depending on the nature of the text, some sentences might not express any sentiment and therefore cannot be classified. Entity, or object, and attribute, or aspect or feature, level. An entity is typically the target of the opinion. In the previous example, the target of the review is clearly the TV, which is the entity for the entire review. However, in many sentences, the sentiments reflect the reviewer's opinions about attributes, or aspects or features, of the entity. For example, in the second sentence, great size, great picture, easy interface, positive sentiment is being expressed for 3 specific attributes of the entity TV.
Hi everyone. Today we're going to talk about machine learning applications to sentiment analysis. Essentially, the task is to classify a short paragraph of text as being positive or negative. More specifically, the example we'll be working with in detail is that of movie reviews. and we'll be looking at how you can automatically decide if a review is good or bad. So why sentiment analysis? Sentiment analysis is a task that's becoming increasingly important for many companies because of the emergence of social media sites such as Twitter, Facebook, and the other trillion of them. For example, a company may want to track tweets about their brand to monitor their impact over time, or a news website may want to analyze comments posted on their articles. Politicians could use it to track their campaign by looking at comments around the internet. There was a website that used sentiment analysis to accurately predict the winner of the American Idol. In short, we are literally swimming in comments on the internet, and we need automated systems that can make sense of them. So as I mentioned, we'll be working with movie reviews in this video. The machine learning approach to things is, again, if you want to do something, first collect as many as you can examples, and then write algorithms that look through them and quote-unquote learn from them. And that's what we'll do in this case. So I found a dataset somewhere on the internet that contains 5,000 positive and 5,000 negative reviews. They basically just come in a text file, one per row, and examples of these reviews are shown here in green and red. Now, given all these examples, we'll try to think about how we can write an algorithm that can take another arbitrary review and decide if it is positive or negative. Now, before we move on, I need to put you in the right machine learning mindset. Contrary to what you may think or expect, machine learning is not about understanding the data in any meaningful way. The task that is ahead of us here, and that will be ahead of us in any machine learning problem, is better compared to simply pattern analysis. The way to look at every one of these reviews is that they are basically only a sequence of symbols. Here, to show you a task that is more equivalent to what we basically expect our algorithms to do, I've replaced every character with a different character, to prevent you from right away understanding the sentences on a high level and using your knowledge of the world. This is a much better portrayal of what our algorithms are up against. It's all that they're given. Something about these 10 green sequences makes them good, and something about these 10 red sequences makes them bad. So the way our machine learning algorithms work is not at all the same as you or I do when we read these sentences. They don't have years of data and experience, and they aren't intelligent. I'll come back to this point a bit later. For now, take a moment to briefly look through these reviews. Pretend you have 5,000 of each, and let's consider some other review. So how could we leverage our 10,000 example reviews to classify this one? Well, one obvious approach could be to try to find a very similar sentence somewhere in our training set. But it's hard to think about good ways of comparing sentences. I mean, when are two sentences very similar? If they contain many words in common? Do these words have to occur at similar positions? Maybe the length of the sentence should matter, but how? In other words, there are many ways you could go about finding the most similar sentence. So you could certainly try doing something like it, but in this video I'm going to show you a slightly different approach. The key to this simple approach is to notice that very often, simply the presence of good words, such as sweet and pleasant in this sentence, can be a good indicator of the goodness of the entire review. In fact, if you were to look through the entire training set, you would find that the word sweet occurs 46 times in good sentences and only 22 times in the bad sentences. So that's pretty good. You could imagine calculating the goodness of this word based on these numbers. The total number of times we've seen it in the train set is 46 plus 22, or 68, and of those, 46 were good reviews. So the goodness of this word is 46 divided 68, or 68%. So it seems like simply the presence of a good word such as sweet right away indicates that this sentence has a pretty high chance of being a good review. Similarly, you could look at all the other words. If you do the same thing for the word pleasant, you would find that the goodness of pleasant is even better, it's 71%. But there are some relatively bad words in this review, such as forgettable. The goodness of forgettable is only 41% based on our training set. So some words are good and some are bad. Now, what about words such as its, which occurs in the very beginning here? Well, its is not really a descriptive word. You would expect that its presence shouldn't be very correlated with the goodness. And in fact, that is what you find. It occurs just as much in bad and good reviews. In other words, its goodness is 0.5. So we can summarize our findings in a table. For every word, we can compute its goodness by looking at our training set. And in this case, it looks like we have many more good words than bad words. So a very simple thing we could do right away is to, for example, sum it all up, and we find that we have many more good words than bad words, and therefore we should predict that this review is good. And in this case, at least, we would be correct. So to recap, we've come up with a quote-unquote learning algorithm. We classify every review by looking at what words are in it individually. If there are more good words than bad, we'll predict good. Otherwise, we'll predict bad. So one thing to note here is that we are completely disregarding the location of these words. People will sometimes refer to this kind of approach as a bag of words model, because these words might as well have been given to us in a bag. We don't make use of the order. This classifier is also very similar to something called the naive Bayes classifier, because we treat each word completely separately from any other word. So for example, the goodness that sweet contributes is 68%, regardless of any other word in this sentence. If there was a not right in front of that sweet, it would have still contributed the same goodness, even though the sentence would now be saying that the movie is not sweet. So clearly, our algorithm doesn't understand anything. It does some kind of counting based on matching words to words in a training set. Despite this, if you give the algorithm another 500 reviews that are not in a training set, it still achieves 80% accuracy. In other words, it will get 400 of them correctly classified and only makes mistakes on 100 of them. That's not a terrible accomplishment given that we're doing something so dumb. And in fact, this example perfectly illustrates the nature of machine learning. We aren't in the business of doing the right thing. We aren't in the business of understanding. We are basically in business of hacking things together until we do pretty well. And in practice, if you hack enough, it's actually quite surprising just how well you can do without understanding. Anyway, let's look a bit more at some of the properties of this classifier. Here are, for example, the top 10 best and worst words. They kind of make sense. Gem, engrossing, vividly, wonderfully, polished, versus unfunny, badly, poorly, pointless, offensive. And here are examples of reviews that were classified incorrectly. Take a look at the first one. This movie makes Catwoman look like a great movie. Can you really blame the classifier for getting this wrong? How is it to know that Catwoman is a terrible movie that should never have been made? How is it to understand the hidden meaning behind these words? The second one is even harder. I would argue that not even I can classify that sentence. The third one is also very similar. The last one is very hard too. The review here is beyond what exists in the words. You have to understand it to classify it. Now let me go on to more fun things. For your benefit, I've coded up the entire classifier that I discussed here in Python, and I will be posting the code and the entire dataset to the website that is associated with this video. Check the video description for that. What you see here is the whole thing. We read in the good and the bad reviews from text files, we count all words and how often they occur in each class, then we go over every test sentence and classify it, and finally we compute our accuracy and print the results. I also tried to comment it as much as I could, and I really encourage you to check it out and try to play with it a bit. If you're new to Python, it will take a bit of initiative on your side, but I'll post some links to help you out with that. So you could try slightly modifying what I've given you to see how well you can do. I was able to get 80% accuracy, which corresponds to error rate of about 20%. See if you can outdo this by making some changes. For example, maybe the words that are very, very good should count for more. That should do a bit better, right? Or maybe you could change the goodness based on the punctuation. So if there are many exclamation marks in a sentence, for example, maybe that's good. Or maybe the length of each sentence could hold some information. Or if there is a not in front of a word, maybe the goodness of that word should be reversed. So those are just some examples to get you started. Now, as I said, this is a very simple approach to text classification, but my goal for this video was primarily to show you a concrete example of how a machine learning algorithm works. In summary, we will always have a training set that contains many examples of something. In this case, it was movie reviews. You then write algorithms that go through the training set and analyze it somehow. We sometimes say that we train a model, or that we learn a model, or things like that. In our example, that corresponded to counting the frequency of each word in both the good and the bad reviews. After that, there is always a testing phase where you are given novel examples of data that your algorithm hasn't seen before, and you use it to evaluate your algorithm. In this case of classification task, we were given new movie reviews, and we determined that our algorithm was able to get 80% of them correctly classified. Some better algorithms could do much better, maybe 85 or 90%. But the common benchmark is always, how well does your algorithm generalize to novel examples? Was it basically successful in learning? Alright, that's it. In my next video, I will go beyond the simple algorithm that I've shown you here. I will explain some of the common techniques for working with text in general, and if you apply those, you can almost certainly do better than 80%. Maybe you can take it up to 90. Anyway, that's it for now. Thank you for watching, and bye-bye.
Example. Testing results from the negative directory. Often a hierarchical taxonomy is used to represent an entity and its various attributes. Sentiments can then be applied to each attribute. In the example, the TV is the root entity, object. Each non-root attribute, size, picture, and interface, is a component or subcomponent of the root entity or object. You can express an opinion about the root node or the object, TV, or any components or subcomponents. In SAS Sentiment Analysis Studio, the term feature is used instead of attribute and the term product is used instead of entity. These terms are used hierarchically in the sense that features are nested in a product. Some challenges in sentiment analysis. Natural language processing, NLP, problems. Sentiment analysis starts with text data. So, all of the typical NLP problems associated with analyzing text data, such as correctly identifying part of speech tags, disambiguating terms and lexicons, correcting spelling errors, and so on, can plague sentiment analysis. Polarity of sentiments are context dependent. Certain opinion words whose polarity is always the same, independent of the context. An example is the word beautiful, which expresses a positive sentiment. There are also context-dependent lexicons in which the polarity of the word depends on the domain or context. Example, the sentence, "The size seems small," can be positive for a USB flash drive with 1 TB capacity. But, the same sentence can be interpreted as negative if the context is an LED big screen TV. Nature of text. Symbolic text. Example, tweets often contain a lot of characters, such as RT. Retweets, hashtags, emoticons, such as smiley faces, that need to be handled carefully. Idiom lexicons. Example, phrase like "it cost an arm and leg." Colloquial text, phrase like variation. Approach of doing sentiment analysis. Supervised. Typically performed at the document level. Using labeled, positive or negative, documents, any commonly used classification models, example, decision trees, can be trained to classify the sentiments of new documents. Unsupervised. Typically performed at the sentence level. 2 approaches. Lexicon-based. Syntactic-based. Lexicon-based. It uses lexicons, opinion words, and involves identifying which opinion words are related to which attributes in a sentence. For example, in the sentence, "the picture quality is outstanding," The opinion word outstanding and the attribute picture quality share the same dependency relationship with the verb is. Hence, the sentence is deemed to be expressing a positive sentiment about picture. Syntactic-based. Syntactic pattern-based approach involves defining part of speech tags and the keywords and, nor, or, not, but, etc. For example, a simple pattern such as subject, not, verb can be used to extract negative phrases like, this feature does not work as advertised. This approach is used in rule-based models for essay. SAS Sentiment Analysis Studio Overview. SAS Sentiment Analysis Studio is a comprehensive solution to the multifaceted challenges of analyzing sentiment in input documents. It enables users to automatically evaluate the opinions and feelings expressed about an entity, or object, person, event, or experience, either at the entity level or at the attribute, or feature. SAS Sentiment Analysis Studio can use statistical models, such as naive Bayes classifiers, rule-based models, using advanced linguistic technologies, or a combination of statistical and rule-based, hybrid, models. The training corpus typically consists of documents that have known class examples of sentiments, such as positive, negative, neutral, and unclassified. These are often compiled by domain experts. It should be similar to the same type of documents to be predicted. The software first extracts linguistic features from the training corpus. Then, using those linguistic features as inputs and known class examples as targets, the software trains and validates several statistical models and identifies the best model. The linguistic features are used by subject matter experts to write linguistic rules that are used in training and validating rule-based models. Hybrid models are created and tested by combining rule-based and statistical models. Any of the developed models can be used to score new documents. SAS Sentiment Analysis Studio Models. SAS Sentiment Analysis Studio enables you to build the following types of models to predict sentiment: statistical, rule-based, hybrid. Statistical models. Statistical models are built using a collection of training documents that have been pre-classified according to sentiment. A large number of good quality documents is required. Statistical models can be very effective in predicting the overall sentiment of a document. They cannot predict sentiment at the feature or attribute level. Rule-based models. Rule-based models use user-written linguistic rules. Users can choose from several rule types to write flexible and powerful rules. Rule-based models can be used to extract sentiment at the product level as well as the feature level. Hybrid models. Hybrid models enable you to combine a statistical model and a rule-based model to take advantage of the benefits of each. The user sets the percentage that each model contributes to the final result. The end of the lesson. Goodbye.